Hello everyone, welcome to Code Enzyme. In this video, I decided to make a tutorial video on this problem, D Scarecrow from Codeforces around 996 Div 2. Basically, as you can see, I solved it last hour only. I found the solution in the editorial quite complicated, and so I decided to explain it in a simpler way using my solution. Okay. So yeah, now let's first read the problem statement. A crow is sitting at position 0 of the number line. There are n scarecrows positioned at integers a1 to an along the number line. These scarecrows have been enchanted allowing them to move either left right at the speed of 1 units per second. Okay. The crow is afraid of scarecrows and wants to stay at least at distance k ahead of the nearest scarecrow positioned at or before it. And to do so, there are some conditions like this one. So if the current scarecrow is at position x, and let the largest position where the scarecrow such that y is less than equals to x, then x minus y is that is x minus y is less than k, meaning the scarecrow is too close, and the crow will instantly teleport to y plus k. The important thing to note here is y is less than equals to x, right? So if the scarecrow is on the right of the crow, then it will not move. Even if the distance is less than k, it will wait for the scarecrow to reach at least at the position of the crow, and then it will move. Okay. This teleportation happens instantly and continuously. The crow will keep checking for scarecrows positioned at or left of him, and teleport whenever one gets too close. Your task is to determine the minimum time required for the crow to teleport to a position greater than or equals to L. Assuming the scarecrows move optimally to allow the crow to reach to its goal. For convenience, you are asked to output twice the minimum time needed for the crow to reach the target position L. And it can be proven that this value will always be an integer. And in this video, I will not be proving that this value will be an integer, because I don't really know how to do that, and I will just assume that it will always be an integer. Okay. Now note that the scarecrow can start, stop, or change position at any time. Okay. Now let's first discuss all these test cases one by one, because that will only give you the clarity how to go about this problem. So first test case is 1, 3, and 5. So we have 1, 3, and 5, and the position is 0. There is only one scarecrow at position 0. Okay. So let's say at time t equals to 0, since this is already at position 0, so we had condition that if the position of the crow was x and the position of the scarecrow was y, and y is less than equals to x and y plus k is less than equals to x, then x will automatically move to the position y plus k, right? Yeah. So clearly at t equal to 0, it is already at position 0, so the crow will move to position 3, right? And then there is scarecrow at position 0, and there is a crow, pardon my drawing, it is at position 3 at time t equals to 0, right? So both will move for 2 seconds like this, or for 2 seconds it will move 2 units right, and this will simultaneously move 2 units right to reach the position 5. So total time it takes will be equals to 2 seconds, and hence the answer is, since we have to print twice the minimum time, the answer will be 4 for this test case. I hope that was clear. Yeah. Let's discuss this test case. I think this will give you more clarity. Okay, so it is 3 to 5. So we have 3, 2, and 5. Next we have 2, 5, 5, the position of the scarecrows. So 2, 5, and 5. Okay, so let's say at t equals to 0, the crow is sitting here, right? And there are scarecrows. One is at position 2, and 2 of the scarecrows are at position, let's say position 5. Okay. Now obviously, since all the scarecrows are towards the right, the crow will not move. Crow will simply wait at this position. So let's say this scarecrow starts moving left. Wait a second. Okay, so let's say this scarecrow starts moving left and this scarecrow also moves left for obviously we have to wait 2 seconds and then only this will reach here. So let's say 2 seconds, one of these scarecrows will move left. Okay, now let's say, or let's for now let's forget about this. At time t equals to 2 seconds, what will happen is this scarecrow, we are only looking at this, and this scarecrow will reach here, right? And the crow will move to position 2 because k, this is n, this is k, and this is l, right? So this will and the positions will be reversed now. Okay, so this is at position 0 and crow will instantly teleport to position 2. And now we have the scarecrow. So clearly the distance between them is 3, right? 3 units, and in 2 seconds it can maximum reach to position 3, right? So obviously to to minimize the time, one of these scarecrow should go left, right? So what this is going to do is what will happen is this scarecrow will move towards left and reach position 3, and one of the scarecrow will be at position 5. Okay, so now this distance is 1, this distance is k, which is equals to 2. So now what will happen is this scarecrow will start moving left, sorry, right, and this scarecrow is moving right and left. Now since this scarecrow is moving the 0th position is moving right, this will also move right with 1 units per second, and this will move left with 1 units per second. So these two will meet here at in only 0.5 seconds, right? So these two will meet in only 0.5 seconds. So let's say at t equals to 0.5, let me just erase it, so I don't really need it right now. Okay, so let's say at t equals to 2.5 seconds, what will happen is we will have this is the 0th position, this is the 0.5, we have one scarecrow currently going more right. This crow will move 0.5 here. So we have at 2.5 position we also have we have one crow and we have a scarecrow, they both are together, right? And this is at position 5. Okay, so obviously this crow will not stay here, it will go 2 units rightwards. So let's just erase it from here, and then the crow will reach somewhere here, right? Sorry, not this one. Let's say this is my crow. Okay, so the crow is at position 2.5 plus 2, which is 4.5. Okay, now this fifth one, which was at position 5, it has 2.5 seconds, and in these 2.5 seconds it can go here also or it can go here also. Obviously since it can go to it has to go leftwards to make this move, right? So what it can do is it can go to 0.5 units leftwards and stop here. Okay, so since it can, it will go 0.5 units left and it will stop here waiting for this to come at 0.5. And let me just erase this one from here. Yeah, so it will automatically make the crow move plus 2 units, right? So the crow will not be there anymore, and it will move 2 units to the right. Okay, so this is 4.5 plus 2 is 5.5, 6.5. So it is at position 6.5 at t equals to 2.5 seconds. So that is how and since 6.5 is greater than L, which is equals to 5, so our answer is into 2, which is equals to 5. That is the output. So yeah, that was the output. Yeah, now I think you can just try to solve all these test cases. I think I will just discuss the last test case because that is pretty big one. Okay, so let's say 9, 12 and 54. We have 9, 12 and 54. Okay, and the array is 3 3 8. We have 3 3 8 and 24 25 27 24 25 27 okay, 25 27 29 34 and 53, 29 34 and 53. Okay, now the problem is like okay, at t equals to 0, what will happen? At t equals to 0, we are at position 0, right? The crow is at position 0. Let's say I will not draw a crow. I will just say like C is at position 0, right? And the first scarecrow is at position 3, right? So what will happen is, let's forget about the others for now. So we have no choice, but we have to wait for this crow to come to position 0, right? Otherwise the crow will not move. So let's directly go to position at times t equals to 3, right? So what happens, like this scarecrow comes at position 0, and the crow will move to position 12 somewhere. Sorry about that. Somewhere in this range, like we have 3 3 8 and 24. So let's say the crow is at this position 12. Okay, now let's see what this scarecrow will do. Now since this scarecrow, let's say it is at position S, it was at position 3, right? So the distance between these two is currently how much? It is distance is 9, right? And 9 is less than 12, but it will try to make the crow move more towards right. Okay, so what it will do is it will go in the right direction. Okay, so it has 3 seconds, so it will move to position 6 actually. So at this time, this scarecrow, the second scarecrow, will try to make it to position 6, and this will make this crow move more right. So 6 plus 12 is 18. So actually this crow will not go to position 12. It will directly at equal to 3 seconds, it will teleport to 18th, right? And now let's see what this scarecrow will do. It is at position 8. Now this scarecrow has 3 seconds, so it can go 3 units left or 3 units right, and it will try to push the crow more towards right. So obviously we should go right. So it will not stay at position 8, it will stay at position 11, and 11 plus 12 is how much? 323, right? So the crow will not be at position 18 actually. The crow will be at position 23. So let me just erase it. Okay, so and the crow will be at position 23. Okay, now let's talk about this scarecrow which is at position 24. Now this crow can go leftwards to 21, or it can go rightwards to 24 plus 3 is 27. So obviously there is no point in going right. It can easily cover this. So this crow can easily, in 3 seconds, it can easily wait for the crow to come at position 23, right? So what will happen is these two will exchange the positions. So the scarecrow will actually stay at this position 23 and wait for the crow to come at position 3. And when the crow teleports here, he will see that there is already a scarecrow, and he will move 12 units to the right. So since he is going 12 units to the right, so we will have 23 plus 12, which is 5 and 35. Okay, so let's say the crow is at position 35. So this is the crow, and he is waiting at now position 35 already. Now we also have one scarecrow at position 25. Now it also can go to the right by 3 units or left. There is no point in going left, so let's go right. So it is at position 28 now, and this will try to push the crow more, right? So let's add 12 here. 10, 3 plus 1 is okay, 40. So now this scarecrow is at position 28 and our crow is at position 40. Now let's talk about this one. So now 27, obviously it can go more to the right. It should go right because we are already ahead. So it will go 3 units right. So this Scarecrow will go to position 30 because it can only go here, and it will push the crow 2 units more. So our position is now 42. Okay. Now we have another Scarecrow at position 29. It can go 3 units right. So it is 32. So this will push the crow more by 2 units. Let me just erase it and clear some space. So this will become a Scarecrow at position 32, and our crow will move to position 42. 44 at time t equal to 3. Now we also have a crow at position 34. This is a problem now. Okay, so let's say I have a Scarecrow at position 34, and in 3 seconds it can go to 37, right? So let's say this position is 37, and this will make the crow at time t equals to 3 move to 37 plus 42. 12. So 949, right? So the crow will simply move to position 49 at t equals to 3. I am here, and the last Scarecrow, if you see, it is at 53, right? Now the distance between them is how much? The distance between them is almost 4 units, right? So in 3 seconds this Scarecrow can maximum reach 50, right? So let's say it is at 50 now. So let's say this Scarecrow is not at 53, it is at 50, and the distance is 1. Now this Scarecrow will be pushing it to the right. So this Scarecrow is moving to the right by 1 units per second, like that, and this Scarecrow is also moving left by 1 units per second. Okay, so they will reach, these two Scarecrows will reach here at around at the distance of 49.5, and then the Scarecrow will teleport, and how much it will teleport? It will teleport by 12 units, right? So it will go like 5, 9, 10, 11, 1, 4 plus 1, 5, 61.5. So at t equals to, okay, and this will happen at t equals to 3.5. In this situation is happening at t equals to 3.5. Okay, this one meeting will happen at t equal to 3.5, and then the crow will reach 61.5. Okay, I can't, I need to scroll. Okay, sorry, 61.5, and the Scarecrow will be here, it will not be here. Okay, and now if obviously since this is greater than L we had was 54, so our answer will be 3.5 into 2. But if my L was somewhere like 70, then my answer will be something different. I will have to wait for the crow to cover this much distance, right? I think it is 8.5, right? 5, yeah. So I will have to wait for the crow to, since this Scarecrow will now change direction, and it will push the crow by 1 units per second. So I will have to wait for the crow to cover this much distance, and then I will reach my answer. So I hope by this example the question is quite clear to you. And now let's see the code. So simply first of all I'm multiplying everything by 2 because I don't want to I don't want to go in the float numbers. So let's first sort it. I think it was given in the question that everything will be in sorted order, but if not, for safety purpose you can just sort everything. First of all you have to wait for the first Scarecrow to reach the position 0. You can't just start like that, right? So you will have to wait for this Scarecrow to reach position 0, and you will move to position 12. Okay, right? And then start with 1. Obviously if it is greater than equals to 12, then you don't need to go further, you are already at your destination. Now there are two cases: AI is greater than position or AI is less than position. So obviously if it is less, like we had in this case, I am at position 12 and this is at position 3, and 3 plus 3 is 6, and the distance between 6 and the current position is less than k. So the crow will automatically teleport to 6 plus 12, which is 18, right? So that is what we have. If I can, the maximum index that I can reach is if the current position of this scarecrow plus k is greater than equals to position, the position will be updated to can reach plus k, right? Otherwise we do not really have to handle it, because after this loop ends we are already handling it here. So I hope this is clear, because at any point of time we will have a scarecrow on the left which is continuously pushing me to the right by 1 units per second. And in this case, if it is further like we have here, like here, first of all, I should try to see, like in these scarecrows I was trying every time, like you can see, like it can go at t equals to 3 seconds, the time that we have accumulated so far. It can go to the left by 3 units, or it can go to the right by 3 units. And if this falls in our range, then like if this can reach is equals to position, like I'm taking the maximum because I'm subtracting it, but if this can reach is exactly equals to position, then the scarecrow can wait on that position for me, and I will simply add the k to the position. I will not use any time in doing that. Otherwise, if this was the case, like this one, like it could not reach in time, then just calculate the difference, and according to the claim in the question, it will always be divisible by 2. So yeah, just divide this by 2, and this is the amount of time that it will take. And now there is one single case, like if while traveling, like I have a crow here and a scarecrow here, and this distance, let's say, is 20, okay, and there is somewhere here in L, so you have to tackle this like this, because these two will meet in 20 by 2 is 10 seconds, right? But you could have this kind of case here, so you can explicitly handle it here and break out of the loop. Otherwise, just time taken will be like the meeting point, they can meet in the between, and just add the position plus k in the final position. Like this is the total 2 times distance, so this is the distance d, and here from here it will go to d plus k. So this will move left, this will move right, and once the crow reaches here, this will change the position to here, continuously pushing the crow to go right. Okay, and if the position is reached, like so, then you can directly do it. Otherwise, if it is still less, then you have to wait for some time for the crow to walk from the current position to the last location. So I hope this was clear, and if you were able to understand this, kindly like this video, and I will see you guys next time. Thank you.